of a cone on top of a cone, and they call this a double-naped cone. Isn't that weird? It looks like double-napped cone.
I could go for a double nap.
But I have these cool little shapes I'm going to show you of how you make all conic sections. So if you take one of these cones and you just slice parallel plane to the cone, then it makes a perfect little circle. That's how you get a circle. And if you take one of these planes and you slice it at an angle all the way through, then you get like an oval, or we call that an ellipse, which is really just like an uneven circle. And if you take one of those and you cut it like this, then you get a parabola. This would be a parabola opening up or a parabola opening down. We've been talking about parabolas for a long time. Since algebra 1, you've been talking about quadratics. But in conic sections, we talk about parabolas that can open side to side also. And then the weird one is a hyperbola. And a hyperbola is really just like a parabola that's opening up and a parabola that's opening down, equidistance apart. And that's just where the double-naped cone comes into play, because you have to have two cones together like this. My kids like to play with these sometimes, like my children. Alright. Why does this say math correctional facility? Not so sure. When Mr. Dorset was here, he used to give people math tickets and send them to math jail. So I'm guessing it has something to do with that.
Oh, no, it's weird. Is like we were working out in the flagpole, and this weird lady pulls up, it's like, I'm totally lost. You know where the correctional facility's at? And we're like, that way.
She was just looking for the, hopefully just going to visit, right?
Well, basically, this is equal correctional facility for children.
So I think the only conic section that I'm really going to make you be responsible for is circles. Something to be aware of, those of you that are seniors in here, you take your final 2 days before the rest of us take our final in here. So you're going to need to get your review a little ahead of time, and, you know, be a little stressful for you. But,
I'm saying we, but honestly,
Trevor.
Well,
And Taylor.
And Taylor.
They're not.
Right. Yeah. But yeah, so you guys will take your final on that first Tuesday back after our 3-day weekend. We're gonna start reviewing for finals on the 22nd, but I can give you seniors your review like on that Monday or Tuesday so that you can have extra time. But we'll probably be taking like a quiz or a quest sometime in here over our last semester. So.
Oh my gosh.
I know.
Sounds 2 full weeks left.
I know. It's out of control.
What in the world? This is so awesome.
All the conic sections are defined about a point equidistance. Mason tried to have the argument with me today that a circle is just a polygon with infinite sides, and I disagreed with him because a circle doesn't have any sides. The definition of a circle is it's all the points that are equidistant from a fixed point, which is called the center. So any point on that circle is the same distance away, and that's where we get the radius from. And you just need to know this formula. X minus h squared plus y minus k squared equals r squared, where r is your radius and your center is at h and k. Which we talked about this way back at the very first chapter. I gave you the equation for a circle. We didn't do a whole lot with it, but I said, you know, it shows up sometimes. What we did in chapter 6, sometimes when we were changing from polar to rectangular and you checked the back of the book, your answer didn't match because they were writing it in this form. And we went through one of those. That's what I was telling second hour about that Sam's talking about on his test. He remembered that, and he completed the square and made it look like this, and very impressive. But I didn't make you do that because we didn't practice it. If the center's at the origin, that would just mean h and k are 0. So look what you get. X squared plus y squared equals r squared. And basically today, we're doing 0 trig. How long has it been since we've done a lesson without trigging it? Like since January, I think.
I don't understand it. I kind of like it.
That's what they said in second hour. I'm kind of used to it now. I kind of just rather do trig.
No, I'm good. Let's keep doing this.
But at the beginning, like chapter 4, I was like, mind explosion.
You know what really sucks? This has been bothering me like for a long time now. Like we're good right now, you know, and we've been doing it. And we're so good. I just wish that I knew all that I know now when I started it. You know? And like, because like I look back at the stuff that I struggled with before, and now it's easy. That just makes me so mad.
But that's, I mean, that's life, right? Like, if it's like, man, if I only knew the math like, if I would just go back and start over in 7th grade but be this smart, school would be so easy. But that's just silly. Like, you wouldn't want to be this smart in 7th grade. Then you wouldn't have more to learn. Like, you should look back and just think how far you've grown as a, like, just be happy of, wow, look how much I've learned. And remember when this used to be difficult? Now it's so easy.
But now we're
Don't
not
be mad
doing
about it.
anymore, so it's no point. There's no point in it being.
We have a final still. Don't forget about that. How about this next slide, just to throw you off a little bit? Whoa.
Oh, I didn't finish.
Oh my gosh, Sam.
That's the first.
We actually added some color.
It's only one slide.
So I've been on the side all year.
Maybe. I used to try to make my slides colorful, but then people need to print their notes off, and let me tell you, go try to print that page off, and you're gonna use a lot of ink.
That was Mr. Gilman back in 7th grade. Pre-algebra. They used to always be coloring.
Yeah, I used to always make mine, and then I had kids that needed copies of notes, and then kids always asked for copies of notes, and now I kind of put it on you to print them off, but still I try to think about your ink or your toner when you're printing them, because that next slide not so good to print. So I think in calculus I have this one, inverse trig functions, derivatives. I have them pink. It's like the only lesson all year. You're good, Sam? All right, maybe before you go off on your next tangent, that you should write down the notes first. You know what makes me mad? That's what you. What?
I don't know. I'm just really talkative today.
I know, it's probably because you didn't get to do the announcements.
Well, I was supposed to go there and help him. Like, that's my fault. Like, I was supposed to go there and like walk him through it, and like I just didn't do that.
You just did it.
I just had to figure it out. Bless his heart. Like,
I like how he just had Emily do the pledge. Like, I felt like he was just like, whatever, just do it, I give up.
do it. Because I had Ryan like literally walk me through everything. Like he was there for like the first.
Way to
5
go.
times.
Way to let down the next student body president.
I dropped the ball.
Oh, I know. I was thinking as Emily was doing hers, as Emily started talking, I was like, oh, I wish I.
Saying will get better though. He really will. It just takes time.
I need happy on the announcements.
Am I happy?
Like gives it like a full pot of coffee.
It is. You do. Yeah. They need to. Well, you just need to help him so that he reads through them ahead of time, so that he knows what's coming. Like I felt like that. He just needed a little practice today.
Yeah.
But should have had a run through before the actual one. We're recording right now, just so everyone's aware. We love you, Zane. So I picked a pretty easy one here. I gave you the endpoints of a diameter of a nice vertical line here. When we're writing an equation, I'm going to change my colors here. We need to be able to find the center, x minus h squared plus y minus k squared equals r squared. So we need to find the center of this, and then we also need to find the radius. And because it's a nice vertical line, could we just say the center would be, well, if this is at 2 and this is at 2, do you agree that this has to be at 2 also? And how would I find the center or the halfway point on this one, do you know? Back in geometry, we had a midpoint formula. Don't really have to do the midpoint formula on this, but anytime that you're looking for the middle point, you can do the midpoint formula. So just so you're aware, if you have 2 points, like x1, y1, and x2, y2, the midpoint formula says that you add the and you add the y's, and you divide it by 2. So if I took 2 plus 2 and divided by 2, I would get 2. To find the y coordinate, we could take 8 plus negative 2, should be 6, and 6 divided by 2 would be 3. Didn't really have to do that one because it's vertical, but if that wasn't a vertical or horizontal line, you can't just count it. Like, you really have to do the midpoint formula, and so that's something you want to make sure that you write down.
Better than on my bonus question yesterday, midpoint.
Yeah, I don't think that'll help. I think you had to do log cosines. Like, it was a terrible game, extra.
Cosine.
I was getting
Holy
so
crap.
excited after like 10 minutes. I'm like, what is it?
Yeah.
It's log cosine.
I think it was log cosines. There's a question in our homework, like, it was just me being mean. That's all it was. Like, we had a question on our homework, and I was like, I made a big point of like, you should read your book and see how to do this example. It's just like it. Read your book. And then that's exactly what that question was, and I just was mean. It was just mean.
And then one,
But the second extra credit wasn't bad. I mean, people got that one.
That 2 on the bottom, is that always 2?
Yes, because you're taking half of it. It's like the average of the 2 points.
Is that parentheses?
Mhm.
2, 2, 3.
Yes, sorry, that's my
I
point.
wasn't sure if it was R.
So that's my center, that's my H, and that's my K. What else do I need? I need the radius. And again, I picked an easy one here because this is a vertical line, which means if I wanted to find the distance here, could I just say, how far is it from 8 to 3? Which would be 5. You agree with me on that? Or I could say, how far is it from 8 to negative 2? That would be 10, and half of 10 is 5. That would be a radius of 5. But if it's not a vertical line, if it's a slanted line, you can't count distance like that, right? Which means you have to do the distance formula. Who remembers the distance formula?
It's like the square root or something.
Some good old geometry today.
Wait, give us like the first digits.
B
and then-
Not B.
Square root of x plus squared.
Close. Subtracting. The square root of subtracting your x's squared plus subtracting your y's squared. It doesn't matter in which order you subtract them because you're going to square it. But it's a square root of subtracting your x's squared plus subtracting your y's squared, or maybe you can write the y's first. And I'll show you when we get to the homework that there's one that you have to do the distance formula on. And people get scared of the distance formula because it's square roots, but it's super great because if this gives you your radius, it's always your radius squared. So let's say you get an ugly radical here. Don't ever give me a decimal. Because let's say you do the distance formula and you find the radius is the square root of 13. What's going to happen when you plug that into r squared? It's just going to be 13. So it always works out nicely. Okay, so just be aware, midpoint distance shows up. But this one's not bad at all. So I'm just going to say the answer to this one would be x minus 2 squared plus y minus 3 squared, h and k. And then the radius is 5. Please don't write 5 squared. It drives me crazy. We're in pre-calculus. We know that 5 squared is 25. And that would be your answer. And just remember that it's always minus h and minus k, so these kind of look like the opposite signs when we do that. But that's not a bad problem, right?
Let me guess.
It doesn't get that much worse today, I promise.
Will you hurt her if I put 1 square?
Yes. I might mark it wrong. Back to white. There were lots of people that didn't simplify it on their test, and it hurt my heart not to mark it wrong, but I didn't. I just circled it and wrote simplify. 9 pi over 12. Who leaves 9 pi over 12 as their answer? Lots of people. Oh, it's okay. I can handle it. It's really hot.
Is that window open?
Yes, but it's not helping. It's hot outside too. My ears doesn't work, but other rooms have air. Why don't I have air?
Because they keep this fire.
They hate me. I'm just gonna stand over here.
Miss Dixon, you gotta teach us very inspirational.
What's the center of this? There's nothing there. So, oh, it's still yellow. The center is 0, 0. And if this is the radius squared, then what's the radius gonna be? Oh my goodness. In second hour, we were discussing whether or not we wanted to graph with the compass. I think that's a terrible idea. Like, just make a decent graph, right? Like, I always graph my center, and then you can go up 4, down 4, left 4, right 4. That's a distance of 4. You can't really. Oh my gosh, I can't see these things. Right? You really, this would be 4 out this way, 4 out this way, but you can't really make a dot out there because, again, you can't just count 4 out that way. So you just kind of wing it. Mine tend to look like ellipses more than circles. Not bad. There you go. How about that for a problem? See, doesn't this make up for the terrible test? A little bit?
We'll find out tomorrow.
This one was rough. I mean, I didn't think it was going to be that rough, but... Well, I thought so too, but the grades are definitely not so good. Compared
Was
to
that the second one?
chapter 4.
I actually felt good about it.
They had 4 A's.
That's not as much as one.
That's not very many for them.
4 A's, 4 B's.
4 A's, 4 B's, 1 C, 4 D's, 2 F's. That's what they had.
Somebody in their class got an F.
2 F's, I mean, I forgot. 2 F's. I was just finishing them. I haven't. How about I just say the letter grades as I go through? Okay. Let's keep a tally here. Let's keep a tally here. While you guys write this down.
You said something about sand going on a tangent, and I wanted to make that joke.
I know. Look, tangent line.
Oh. Alright. I know one of those F's.
I know, I
is wrong. Look, that A's not in here. Oh, wow. There's so many F qualities.
That's it.
That's all you access for? Or is that the whole class?
Yeah, I'm one of them.
Is that the whole class?
That's all. I mean, there's still the 3 that are taking it, but that's the whole. That's everyone that's taking the whole thing so far.
That's the A. One H is probably mine. One D. I'll probably.
There were 5 G's though. Like, that's the one that got the most.
Did I get a B? Just tell me. Just
Let's
please
talk about
tell me.
tangent lines.
If I'm not after class.
Yes. Oh, after class you can only see your percentage, nothing else. You can't ask me what your grade is in the class, because I just graded them. Like, they're not even in the grade book yet. Okay, let's just erase that. This is all recorded also.
Someone's gonna watch that video and be like, fun, class, and then I think it's funny how we like,
Yes.
Oh.
Which will be good, right? It should be a good test, hopefully.
You can just retake one part.
The retest is just going to be one test. Like, it's not going to be as long. It'll be good. We'll figure it out.
it'll be easy to
Sound
figure it out.
really.
We'll talk about it tomorrow. Let's just enjoy our circles today.
Until the process. We'll deal with that.
We'll deal with that tomorrow.
Until the process all.
Tangent line, this is a little sneak preview to calculus. In calculus, we talk lots about tangent lines. But the definition of a tangent line is it's a line that intersects a curve, in this case a circle, in exactly 1 point. I know that kind of looks like that it touches it in more than 1 point, but if you zoomed in really close, it really would only touch it in 1 point. That's really all you got to know right now is what a tangent line is. In calculus, we spend a lot of time talking about the slope of a tangent line at a curve at a point, and it's very exciting. It is, but I don't know why that circle's purple, but we'll just go with it. I think I copy and pasted it. But why do you need to know what a tangent is to do this problem? Write an equation for a circle with a center at 3, 5 that is tangent to the y-axis. So you got to know what tangent means. There's some joke about a tangent, like, I don't know, I don't remember.
Not a tan.
Gent,
Like
yeah.
Layton's a tan.
Right, right. And there's some joke about tan lines too, like going to the beach and your tan lines, but you really need tangent lines. There's lots of terrible math jokes. you're a math person, then they're kind of funny jokes. But most other people just groan.
I read the joke on your little
Caitlin was very upset, and that's what I told her my favorite joke was. We're really, it was on your assignment sheet about the chemist and the physicist and the mathematician that were stuck on an island, and they had a can of food, and they were trying to figure out how to open it, and the chemist has this idea, and the whatever has this idea, and the mathematician says, assume we have a can opener. Because, and I just enjoy that joke because it makes me laugh every time. Right, yeah, and then we'll throw back to the assume P1 is true, and you guys all get upset. You don't necessarily have to graph this, but I feel like sometimes visually it helps you to see this. If you graph the center at 3, 5, and you know tangent to the y-axis means it can only touch the y-axis in one point, what does the radius of that circle have to be? Because if it's tangent, if the radius is 3, that means that's the only place it would touch. If the radius was more than 3, then that's going to touch the y-axis 2 times. That's not tangent anymore. If the radius was less than 3, it wouldn't even touch it at all. So you really only need to know what tangent means in order to do a problem like this, because I can say, oh, the radius is 3, and then I can write my equation, which would just be x minus 3 squared plus y minus 5 squared equals 3 squared, which is 9. That's it. That's the answer to it. But it's just knowing what tangent means. I think way back in geometry, you learned that, but it's been a while, right? A secant line is a line that touches a graph at 2 points. So, like if your radius was here, and you drew that in, that's a lovely, that's not right. That was supposed to be the radius, right? I screwed that up. It's supposed to be like this. This would now be a secant line because it cuts through it at 2 points. But if it's a tangent line, it only touches it in 1 point. Like that. So, tangent and secant, you're like, what's that have to, you feel like after we do trig, there should be some relationship with the words tangent and secant and trig, but there's really not. Totally unrelated. Isn't that weird?
Okay. Octagonal, Ryan's trade.
No, there's only tangent and secant lines. Real quick. Because tangent means it can only touch the y-axis in 1 point. So you can only, the only way that you could make that only touch in 1 point is if your radius is going to be the distance from the center to the y-axis. Okay? So, tangent. Alright, here's the algebra of the day. It's not really so bad. Especially Sam, he's got this down because he did this on his test already.
Still probably got an F.
Oh,
You're not denying it.
not denying or confirming. I cannot deny or
You
confirm.
just tell me it's bothering me. I don't care if it's making no sense.
It's not an F, I don't think.
Indeed. I'm gonna take that. I'm gonna take that and be happy with it. I'm good with that.
I don't think you should be happy about it.
Wrong. I'm not stricken with depression or anything. I'm getting used to that.
What?
Thank God.
I cannot deny or confirm. Actually, I don't remember. I don't think you got an F.
I think I got one.
We need to write this in this form. And so when you see x's and y's in these problems, you got to complete the square. And so I always rewrite it, and I say x squared plus 6x, and I leave a spot. I don't have to complete the square with y squared because there's no y to the first power. And then I can move that 7 over to the other side. Sometimes you're going to have to complete the square with x and complete the square with y. And then once you do that and write it in the right form, then you can graph it. So we talked about this in chapter 6, but I said you didn't have to do it. But if we were going to make this in standard form, we would complete the square where you take half of this number and you square it and you put it right here. So half of 6 is 3, and 3 squared is 9. And if I add 9 here, I have to add 9 to the other side to keep it balanced. That's the part that people forget. And then I can write this, it's always half of the middle number, so that becomes x plus 3 squared. And I always just write this as y squared, but you could write it as y minus 0 or y plus 0 if you want to see that k value there. And this one works out really nice. 7 plus 9 is 16. It might not always work out so nicely. But you want to put it in standard form first, because if it's in standard form, then you can tell me the center, you can tell me the radius, and you can sketch the graph of it. So remember that this is the opposite. It's x minus h. So if this is a plus, that's negative 3, k would be 0, and r would be 4. So negative 3, 0. I go up 4, down 4, left 4, right 4. Not so bad, right? I think I only have one more example. How about that? Can I go? And this is really as bad as it gets today, or maybe distance formula is as bad as it gets today. That seems like what they were complaining about in second hour. But this is the most work you're going to have to do, in that you might have to complete the square with both x and y. So I'm going to give you a minute to get a head start. Group your x's together, leave a space. Group your y's together, leave a space. Complete the square with both of them. Put it on the other side and see if you can get this in standard form. We do this with ellipses and hyperbolas and all that too. I just think that I'd rather do some other stuff with you. Some cooler stuff. You're live back there, Jake. You do this already?
Oh, we're supposed to do it right now? So I just kind of drummed out the nose of that truck out there. I just kind of like,
The big thing is people forget the other side. When I teach Algebra 2, I always say if you feel like you're going to forget to add it to the other side, you could leave 2 blanks on the other side of the equal sign 2, and that would be a reminder to add that same thing over there. But here I think we're going to add 4, and here we're going to half of 4 is 8, half of 8 is 4, and that would be 16. So we're going to add 4 and 16 over here, or 20. So that would be x minus 2 squared plus y plus 4 squared equals 25. So the center is 2, negative 4, and the radius is 5. And this is really the majority of your homework today. Questions about this? It always kind of leans to one side.
Okay, what else are we asking for?
Systems of equations. Maybe some matrices. Solving systems using matrices.
I thought we were going to have to use the matrices again.
Let's see.
Do they even, I know you can do this with some stuff, but I was thinking
You can solve equations with them, like systems of equations, and you can also maximize and minimize. Like when we look at the system of inequalities, you can do stuff with it. But you're not going to do this whole worksheet, most of it. But at the top, you're just doing 1, 3, 5, and 7. You're just doing the odds. And then 8 through 15, you're going to do all of those. But 1, 3, 5, and 7, you got to write the equation, which means you have to find the center and the radius. And so I'll tell you, number 5, you have to do the midpoint and the distance formula on number 5. Because the points they give you is not a vertical or horizontal line. That's one they were struggling with. So, but matrices are just another way to look at systems of equations. We might look at how the graphing calculator can do matrices as well, depending on how much time we have. So, we'll see. We'll see how much time we have. different than I've ever done, so. Which means good news for you, since we didn't cover everything, I'll be taking some questions off the final exam. Hip hip.
Alright, so for us, calculus, is that gonna affect our,
No.
no?